Shout out Movie, Period 6. So,
All right. So now we're going to go over Module 4, which goes with Chapter 11, and it's going to be page 158 and 159 in your Gen. So go ahead and make sure you're ready on those pages. All right, so on page 158, the first thing we have these two flaps that go at the top, and so you're going to want to draw these pictures underneath the flaps so you have them. And so the first thing is arc length. Arc length is here is a picture of it, and arc length is the measure of the portion of the circumference represented by the arc. So the length of the arc, okay, is how long a string would be if it connected those two pieces of a circle. So it is a curved line that we're measuring, so we can't just pull a ruler out. We have to use a formula to figure it out, okay? And then arc measure, okay? And so arc measure goes with this measure, and the arc measure is the degree measure of the arc. So if I said, what is the arc measure of AB? Then I know it's 60 degrees because this angle is 60 degrees, which makes this arc measure 60 degrees. And then if I wanted to figure out its length, I would have to use a more complex problem to figure that out. And we'll talk about that in a second of how to do that. All right, and so here we're going to practice naming some arcs. If an angle is given, name the arc it makes. If an arc is given, name its central angle. So these are all on page 158 in your book. So this is 158. Okay, so here they said, we want to know what is this arc. So if I go from X and I go past V all the way to W, okay? And so this is an arc. And so do you see how it's not angle 1? Okay, it's not angle 1, but it would be 360 degrees minus angle 1 because it's all the way around. Okay, from X past V all the way to W. Okay, then it says FE, arc FE. So that's from here to here. Do you see how that goes with angle 2? So the measure of angle 2 is going to be the same as the measure of arc FE. Okay, now they want us to find the measure of the arc or central angle indicated. Assume that lines that are diameters are actually diameters. So if it looks like a diameter, it is. So here they want me to find the measure of angle FCG. So FCG is this part of the circle. So they want me to figure out what is this arc or angle measure. Okay, so if I know this, if I know this is a diameter, and I know this is a diameter, okay, if this is 43 degrees, okay, then I can figure out the rest of this information here, okay? So this is 130, this is 43, okay? These two are the same amount, okay? So this is a diameter, so I know that this 130, so this has to be 50, and this has to be 50 because those are vertical angles, okay? Now this whole section here is 180 degrees. I know I have 43, so I go ahead and take that away. Okay, and then I go ahead and take away this 50 that we found out. And we do this subtraction problem here. And we see we're left with 87. So that's how much this measure of this arc is, and that's also the same measure as the angle. So that angle is 87 degrees. Okay, next problem. They want us to figure out angle TSU. Well, we figured out this is 70, this is 55, and so I can figure out this because this is half a circle. So half a circle, 180. I'm going to take away 70, so that's 110, and then I'm going to take away 55, and so that's going to give me 55, because 55 plus 55 is 110. So this angle here is 55 as well. Now, we're looking for just this piece here. I know this is a straight line. This together then is 110. And so that means that I'm left with 70. Now that's one way to do it, but I could have also realized that these are vertical angles and vertical angles are congruent. So that's another way for me to know that it's 70 degrees. Okay. Next problem, they want me to figure out the measure of angle ECG. So we can see that this piece is 70 already. And I see this over here is 50. I know this is 180. So I can see that this piece here is going to be 180 minus the 50. So that's 30. That's the 130. So it's 130 degrees, angle ECG. All right, now they want me to find IK. So they want me to go from I to K and figure that out. Well, I can already see this piece is 60. I just have to figure out how much is this piece. Well, if you notice, all the other angles are given in a circle. So if I'm looking for these two pieces together, I can just take away these amounts from 360 for a whole circle. So we have a whole circle. I'm going to take away 100. So that's 260. And I'm going to take away 104 so that I can figure out that this angle, this arc measure, the measure of arc IK is going to be 156 degrees. Oh, excuse me, 156 degrees. And I figured that out because I know a whole circle is 360. So you have to keep in mind a whole circle is 360 and half a circle is 180. Right? Now these questions are asking for the length of the arc. Okay, so they're no longer asking for the measure of the arc. They want to figure out if I took a string, how long it would be. So the first thing I want to do is think about it for a second. If I took a string from this point and I went around the circle to this point, I want to know how long it is. Well, the first thing I know is that if I go around a whole circle, that's called circumference. And circumference, the formula for circumference is 2 pi r, or 2 times pi times the radius. But that's the whole circle. This is only part of a circle. So it's 225 pieces out of a whole circle, which is 360. And I got that measured from here. So I take that fraction and I multiply it by the whole formula, which is 2 times pi. And then here they told me the radius was 7. You want to make sure you're using a calculator with these values. So I'm going to go 2 times 7 times 225 divided by 360, and then that gives me 8.75 pi. And so I can now go times 3.14 for pi, and that gives me 27.475, and then it's inches. So that's how long the string is from that one point to the other point. Notice here, 120 degrees. You want me to go from that point to that point. So my fraction is 120 over 360 times 2 pi, and then my radius is 12. So I'm going to go to my calculator and do 120 times 2 times 12. And then once I get that number, I'm going to take it and I'm going to divide it by 360. And that gives me 8. So I have 8 pi. So now I can take and multiply by pi. So 8 times pi is 8 times 3.14. And my approximate answer is 25.12 yards. Okay, hopefully this is making sense. Go ahead and see if you can try the other two on your own before we move on. Okay, pause it, take a moment, and then if you still have questions, come to class and ask those questions. All right, so now this is the little tabs that flip on page 159. So you want to draw these pictures on the back side of your little tabs. So the first thing it says, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of the intercepted arc. So here we have an angle. This angle here is 60 degrees, which means if I take the vertex all the way back to the edge of the circle, it's going to be half. So that means that angle there is half of 60, which is 30 degrees. Then the next one says if two inscribed angles of a circle or congruent circles intersect congruent arcs, or the same arc, they are congruent. So notice from here to here that both this angle C and that angle D intersect the same arc. So that means whatever AB is, the measure of angle AB, is going to be the same for both of them. And the next one says an inscribed angle, if it's a semicircle, then it's a right angle. So if this is a diameter, then I know this angle up here always has to be 90 degrees. If it's a diameter, then that angle is going to be 90 degrees. And the last one says if you have a quadrilateral, so any four-sided polygon where all four vertex touch the circle, then I know the opposite angles are going to be supplementary. So A and C, angle A and C together are going to equal 180, and angle B and D together are going to equal 180. Now we're going to move on to the practice problems that also go on page 159. So it says find the measure of the arc or angle indicated. Okay, so the first thing I need to look is I need to see this is a diameter. So a diameter is a whole, the whole line or two radius put together, and that means that this whole section is 180 degrees, right? And then I also see that this part from here to here is 120. Now we're looking for this angle, and this angle, this vertex of the angle is on the circle. It touches this arc, so it's going to be half. So 120 divided by 2 is 60. So I know this angle here is 60 degrees, right? Notice this is the same kind of picture. My vertex of my angle is on the circle. If this is 62 degrees, then that angle is half of it. So that means this angle is 31 degrees. All right, this problem, same kind of problem. From here to here, it is 90. This measure is 90. The vertex is on the circle, so that means it's 90 divided by 2, which is 45 degrees. Right? And then this one, they're giving me this measure is 112 degrees. The vertex of this angle is on the circle, so 112 divided by 2. And when you do 112 divided by 2, you can see that this angle is going to be 56 degrees. Pretty quick and easy to spot those. Okay. Then the next four are a little bit different. So here, I see the angle is 91 degrees. Okay, so remember the angle was half of this. So what would this have to be for 91 to be half? So it'd have to be two of those. So 91 and 91. So can you see how we get 182 degrees? All right, then this one, it says this angle is 42 degrees. If this angle is 42 degrees, this has to be double it, which means it has to be 84 degrees. So that's how you find the measure of that arc. This is a diameter. Remember when we have a diameter here, this is 180 degrees, which means this angle is 90 degrees. Right, now they want me to find from B to X. If this angle is 68 degrees, this has to be double that amount. So it has to be 268, so you can figure out that however you like. But you can see that it would be 136 degrees. Make sure that if you have any questions over this section, you come to class prepared. This is the end of Module 4.